All right, so let's do another example in DeltaMath with your inequalities. I know the graphing is kind of weird, so I want to help you out with that. This kind of graphing we're going to be using next chapter also, so I do want you to master this as soon as possible, but I am here to help. So for this example, let me get into my annotation. There we go. So the first thing you need to do is solve the inequality. Before we deal with the graphing, we need to solve the inequality. So I have 5x plus 2 is greater than or equal to negative 18. So I'm going to isolate my variable just like we did if we had an equality. And I get 5x is greater than or equal to negative 20. Then I'm going to divide by 5. My 5's cancel. And I get my x is greater than or equal to negative 20 divided by 5, negative 4. Just a reminder, sometimes you do need to flip the inequality, but that's only if this number is negative that you're dividing by. If that number is positive, we're good. So this is my final answer. So that's what I'm going to type. So over here, I'm going to type x, and I'm going to select greater than or equal to, and then negative 4. So that'll be my inequality notation. Now I need to do the graph. So I'm going to do a little rough draft off to the side so I know what to shoot for, what my goal is. So when I graph this guy, I'm going to start at negative 4, and then you've got like negative 5, negative 3, negative 2, it keeps going. For the graph, I'm going to start at negative 4, and it's a greater than or equal to. So the or equal to reminds me this is a closed dot at negative 4. And greater than tells me I want numbers that are greater, larger than negative 4. And I know that's kind of weird with the negatives, but this will always be to, oops, oh dear, come on, Miss Marita, you can draw a line there, something like that, yay. So greater than negative 4, greater thans are always going to the right. Think your number line, bigger numbers are always to the right. So that's the graph that I want to replicate in my DeltaMath. So to do this in DeltaMath, look at these directions down here. Let them help you. I wish they were like flashing and super bright, but it says click and drag to plot the line, or to plot line. So I'm going to click on negative 4. That's where I want my line to start, but this line has an arrow. It goes forever. So I don't want to stop. If I stop here, it'll be a segment. I want to go all the way to the arrow. See how that arrow lit up? If I stop early, it makes another point and looks like a segment. That's not what I want. I'm going to drag all the way to the right and then let go. And now this green line, it started at negative 4 and goes forever to the right, just like my graph started at negative 4, goes to the right. If, double check your directions, if you're like, oh no, I did that wrong, you can just click the line, oops, there we go. Click the line and it'll delete. I didn't do it wrong, so now I have to do it again. Start at negative 4, drag all the way over. The last part I want to show you is that if, for example, maybe instead of a greater than or equal to, maybe it was one of these first two, just the greater than, that would need an open dot. And so, oops, just click once, and that's how you can make this an open dot. That's not what I want. I want a closed dot for my example because I'm a greater than or equal to negative 4. So once you have your inequality notation entered and your graph on your number line, you just click submit and hope for that. Yep, let's go. Let's get that green check. Yay. And then just a reminder in DeltaMath, this will go through the solution, so it gives you nice work and the answer. And then down below, it shows your number line and your solution. So if you were incorrect, you could compare and see, well, what did I get wrong? The last part, always reminding you, you've got help videos here that you can always click on. So if this video wasn't enough and you want to watch another video of an example, click on your watch help video, and you can see another example going through the graphing and the solving.